Good day, my wonderful viewers. Once again, you are welcome to Respectful Education. In our physics class today, we shall be looking at mass and weight. Now, the question is, what is mass and what is weight? Mass we describe as the quantity of matter present in the body, while weight we also define as the earth pull of the body. Now, as we tend to look at these two concepts, there is need for us to understand that mass has its system unit of measurement in kilogram. That is to say, whichever way it tends to appear in our physics problem solving, whether in milligram, in centigram, or in decigram, we are expected, or even in gram, we are expected to do what? Convert it immediately to what? To kilogram. But most essentially, we are going to be looking at the essential aspect, which is the conversion of gram to kilogram. Because most of the questions or most of the basic problems that tends to occur in physics are mostly in grams. So when they are in grams, it is expected that we reverse it back to kilogram, which is the system unit for mass. Now we shall be looking at the conversion processes of mass from gram to kilogram, under which we have this example 1 that says for the I we should convert 600 gram to kilogram, and for the II we should convert 1.5 kg to gram. Now in the example 2, we tend to relate the case of mass and what? And the weight, where we have it that we are asked to find the weight of a body. If mass is 6,000 grams, that we should take G to be equal to 9.8 meter per second square. Now we shall see how we can solve these problems bit by bit. Now for this example 1, we have solution to EG1. In the EG1, which is the I, we are expected to convert 600 gram to kg. Now you should note that in this conversion process, that 1000 gram is equals to 1 kilogram. That is to say, the 1000 gram of a body is equivalent to 1 kilogram. So if 1000 gram is equivalent to 1 kilogram, so we have it as 600 gram will now be equals to xm kilogram. 600 gram is now equals to x what? Kilogram. Here we'll cross and we multiply. If we cross and multiply, we have it that 1000 times x will give us 1000 x to be equals to 600 times 1 will give us 600. So now we divide by the coefficient of what? X, dividing both sides by the coefficient of x. We divide here by 1000. We divide here also by 1000. So 1000 cancel 1000. I have it as x to be equals to. Now we have this 2 0. We cancel this 2 0. Remaining 6 and then 10. Now 6 divided by 10. It cannot. We put what? 0 point. Add 0 at the front of the 6 to become 60. 60 divided by 10 will now give us 6. So we have it as 0.6 what? Kg. So therefore that 600 gram is equivalent to 0.6 kg. That is the conversion from 600 gram to kilogram. Now we have the II, where we have the conversion of the 1.5 kg to gram. 1.5 kg to gram. In conversion of this process, there is need for us to understand that also that 1000 gram, we say IE, 1000 gram is equals to what? 1 kilogram. Then if 1000 gram is equals to 1 kilogram, then let x gram be equals to 1.5 what? Kg. In this process we cross and we multiply. If we cross and multiply, we have it that x times 1 will give us what? X to be equals to 1000 times 1.5. We have it as 1000 times 1.5. Now instead of putting this 1.5, we change this decimal to what? To fraction. Change this decimal to fraction, we have it as 15 over 10. That is when we change decimal to fraction. So 0 here will cancel this 0 here, remaining 100 and what? 15. We see that IE at our S now is now equals to 100 times 15 will give us 1500 what? Gram. So we see that therefore that 1.5 kg is equivalent to 1500 gram. So that is the conversion of kilogram to gram. Now let us look at the example 2, where we tend to rate mass and weight. Remember, we define mass as the quantity of matter present in the body, while the weight is being described as the air pool of the body. So there is need for us to understand that weight is similar to what? To force, because force is being described as either push or pull. So if weight is the pull, the air pull of the body, therefore we can say that weight is the same thing as what? As force. So the unit of force is equivalent to the unit of what? Weight. And what is the unit of force? The unit for force is Newton. So if force is measured in Newton, therefore weight also is measured in Newton. Now say solution to example 2. Now we're meant to understand that because of weight is the air pull of the body, if weight is the air pull of the body, that means it is operating under the influence of mass and what? And gravity. So we'll say that weight is equals to mg. This mg, m is the mass and g is the what? Acceleration due to gravity. Now measured in what? In Newton, which is now equivalent to what? To force. So we can say that weight is equals to mg measured in Newton, and also is equals to force, because force also is measured in Newton. So we'll say that i.e. the m, which is the mass, is equals to 6,000 gram. 6,000 gram. And the g, which is the acceleration due to gravity, is equals to 9.8 meter per second square. That is the g, acceleration due to gravity, is equals to 9.8 meter per second square. So now, before we substitute this concept in this formula that we have here, that weight is equals to mg, there is need for us to convert mass to what? To kilogram. So we'll say that i.e. 1,000 gram is equals to 1 kilogram. Then 6,000 gram will now be equals to x what? Kilogram. In conversion, we have it as 1,000 times x will give us 1,000 x to be equals to 6,000 gram times 1 kilogram will now give us 6,000. So we'll divide by the coefficient of s, divide here by 1,000, divide here by 1,000. So we are expected to divide both sides by the coefficient of s. This is just the application of mathematics. So we'll have 1,000 divide 1,000 to give us x equals to, now this 30, we cancel this 30 here, remaining only 6. Remaining only 6. So we'll have here as what? 6 what? kg. So we can say that 6,000 gram is equivalent to what? 6 kilogram. Now substituting this 6 kilogram into this formula of weight, we have it that i.e. that weight now will now be equals to 6 times acceleration due to gravity is what? 9.8. 6 times 9.8. Remember that this w represents what? The weight. So we say that our weight is now equals to, now remember the multiplication of decimals. So this 9.8 is in 1 dp. So we change it automatically to 98 to be multiplied by 6. Now we multiply by 6. Now we'll say 6 times 8 will give us 48. We have 8 to carry 4. 6 times 9 will give us 54 plus 4, which is what? 58. So we have 5, 8. That is 588. Because of is in 1 dp, we count 1 and we'll put our decimal point here. So we'll have it as Newton. So we'll say that therefore weight of the body is equals to 58.8 Newton. So that is the weight of the body. Now if you watch here, this is an activity for you to also try on your own in regards to what we have just done here in this board. Now we have the I question here, that says we should convert 15.50 gram to kilogram, and the question 2 there, we should convert 2.05 kilogram to gram. Then the question 3, we are asked to determine the weight of a body whose mass is 4,500 grams. Then we should take G as 9.8 meter per second. Try to do this on your own. Thank you very much for joining to this channel.